All right, so today we're going to talk about properties of logarithms. And there are three properties of logarithms: the product, quotient, and the power property. Since logarithms are basically what? What is a logarithm? A logarithm is an exponent, right? And you know that when you're multiplying two powers, right, like x cubed and x to the 7, what happens to those exponents? You add the exponent, right? So there is a connection between multiplying powers and adding exponents, right? So that sort of lends itself to the product property, the quotient property, and so on and so forth. All right, so we're going to start with the product property. Okay? It says for all positive numbers m, n, and b, this is the product property. So it says if you have log b, m times n, that's equal to log of m plus log of n. Why? Let's just take a look at why. All right, so look at this one. I have log base 2 of 8 times 4. Okay, let's zero in on this. This is log base 2 of what? 2 to the 3 times 2 to the 2. Right? So that's really log base 2 of what? 2 to the 5th, right? Which will be what? That would equal to 5, right? Okay, so what about this one? Log base 2. What's the first one? 2 cubed, 2 squared. At the end of the day, what would that be? Does that make sense that that's 5? Right? So if you were to do it this way, or if you were to do it this way, in either case, what do you end up doing? You end up just adding the exponents. And here you end up just adding the exponents. Right? Yes? No? Okay, so that's why if you have log base 2 of m times n, it's just the same as log base 2 of m plus log base 2 of n separate. All right? So, look at this one. You know that log base 3 of 2 is this number, and log base 3 of 7 is that number. All right? Now, all you have is a 4-function calculator, one of these. Okay? And you want to figure out log base 3 of 14 based on what you have here. Well, can we do that? Let's see. First, what I want to do is rewrite this in terms of a 2 and a 7. So I say, okay, log base 3 of 14, that's 2 times 7. Okay? And now how can I use the property? That's really log base 3 of 2 plus log base 3 of 7. Now, do I know what log of 2 is? Yeah, it's that number. Plus, do I know what log of 7 is? It's that number. And now, if I just had my little 4-function calculator, would I be able to add those? What would I get? Boy, this 4-function calculator is no good, actually. Plus 1.7712. What would that give me? Right. Okay. All right. Well, what about the other one? Log base 3 of 63. What then? How can we? Seven times 9, right? Oh my. Well, what about now? Okay, so let's see. This is log base 3 of 7 and of 9. Okay, so this I know, right? Log of 7 is 1.7712. Well, how much is that mess? How much? If you're walking down the street and you see this, how much is that? Two. There we go. Okay, so if you're walking down the street and you see that, I want you to be able to say 2. Okay? Now, without throwing comments, okay, maybe you can't do it now. By, tomorrow, you're going to be able to. By the time we finish with this chapter, you're going to be able to. You've got to be able to. Okay? And it does come with practice, so you're going to have to do lots and lots of practice. So this is 3.7712. Yeah. Well, so we can rewrite it. This is a 3 squared. Remember? And now this and this go away. So it's just a 2. Or what is the exponent of 3? That will give you a 9. 2. Right? Now, here we have the quotient property. So same situation. Now, when I'm dividing powers, what do I do to the exponents? You subtract, right? Is everybody with me today? When I'm dividing powers, what do I do to the exponents? Subtract them. So if I have log bm over n, it's log bm minus n. Okay? So same situation. I can't seem to highlight this. All right, so same situation. Let's do this one. I want to rewrite these in terms of log base 2 of 3 and log base 2 of 7. So the first one will just be log base 2 of 7 minus log base 2 of 3. Okay? Whatever is in the denominator, think of it as, if it's in the denominator, you're subtracting an exponent. Logarithms are all exponents, right? Whatever's in the denominator, the exponent will get subtracted. So it's minus. So now this is going to be 2.807 minus 1.585. And how much is that? 1.232. Who gave me that answer? Huh? Oh, 1.222. And I'm trusting you guys blindly, so don't let me down. Okay? Now, here, what do I have here? Log base 2. Now I need a 3 and a 7. How can I write the 36 in terms of a 3 and a 7, or just a 3 or something? 3 times 12? Will that help me at all? How about if I do log base 2, 9 and 4? Okay, that would be log base 2 of 9 plus log base 2 of 4. Okay, now this I can deal with. The 2 and the 4, I can deal with that. Well, what about the 9? How can I rewrite the 9? Log base 2 of 3 times 3 plus log base 2 of 4. So this is log base 2 of 3 plus another log base 2 of 3, right? Plus log base 2 of 4. So log base 2 of 3 is what these days? 1.585. And how many of those do I have? I have 2 of those. Can I just say multiplied by 2? Plus, how much does that blue mess give me? A 2. So 1.585 times 2 plus 2 is 5.17. Okay?
Why would you do minus?
Huh?
Why would you do a 1?
Well, because they're all being multiplied, right? It's 9 times 4. So remember, you're going to add the powers. Okay, log base 2 of 0.75. Oh my goodness, how am I going to do that one? It's 3 over 4. So that's log base 2 of 3 minus log base 2 of 4. So what's log base 2 of 3? Minus 2. How much will that give me? Awesome. Okay? Now, what about the power property? This is like the fun, this is the fun property. All right. The power property says when you have a power log base b, m to the power of p, the exponent always comes down and it just becomes a fraction. It's like, it's so fun. Okay? It really is. It's so much fun. And okay, so for example, let's do an example. So suppose you have log base 3 of 9. Okay? Now look, this is really log base 3 of 3 squared, right? And the 2 will always come down, and it'll be 2 times log base 3 of 3. Okay? So whenever you have the exponent, it always comes down and becomes a coefficient. Yes? Okay? Yeah, like a power to a power, you multiply the exponents, right? Okay. So here, let's let's solve these. So you can solve logarithmic equations. You can set the arguments equal to each other when the logs are identical to each other, right? Did we do solving logarithmic equations yet? Yeah. Okay. Between my algebra classes, I'm getting confused who's at which point. Okay, so here we go. This is log base 5 of m equal to 1 over 3 log base 5. And how do I write the 125? It's 5 to the power of 3. Now, you know what happens? The 3 comes down. So this is log base 5 of m equal to 3 times 1 over 3 log 5 of 5. I'm only writing it in this much detail for this one problem. You're going to, just do it mentally. So this is log base 5 of m equal to 3 1/3 is 1. And how much is this? That's 1, right? Okay, so now, what would m be? 5. And now you plug it in to make sure that it works, right? And in this case, it does work. Okay, so let's do another one. So here, we're going to condense. We're going to go backwards. Okay, we're going to go backwards and we're going to combine into one logarithm on each side. So here's what we're going to do. We're going to do everything that we were doing with the three, what do you call it? With the 3 properties, but now we're going to go backwards. So all of the coefficients are now going to become exponents. Exponent there. So this is log base 3 y squared plus log base 3 of 0.1 equal to log base 3 of 5 plus log base 3 of 2. Now, remember how you said when you have log base b of m times n, you split it up into a log plus a log? What if you were going to go backwards now? What if you had this log m plus log n and you were going to go backwards? If you're adding the logs, you multiply the arguments. Okay, so we're going to condense and multiply the arguments. So here it's going to be log base 3 y squared times 0.1. Okay, equal to log base 3 5 times 2. Okay, so when the logs are identical, you set the inside equal to each other. 0.1 y squared is equal to 10. Divide both sides by 0.1 or multiply by 10. So y squared is how much? 100. So how much is y? Well, technically it's plus or minus 10. Okay? But when you go ahead and check which one works, y equals negative 10 does not work, so it's only y equals 10. Huh? Yeah, so what you do is you take the negative 10 and you plug it back into the y here. So here you're going to end up with 2 log of negative 10. But you can never have the log of a negative number. Okay? All right. So let's do this one. Log base 7m is equal to, the 1/3 goes up, log 764 to the 1/3, plus the half goes up. Okay, so log base 7m is equal to log base 7. Okay, and what am I going to get here? How much does this give you? 60. It's a 4, right? Now, how much does this give you? 121 to the half. 11. Now, is it times, divided by, plus, minus 11? It's times an 11, right? So now what's m? 44. Okay. All right. I'm going to give you 5 minutes to do A, B, and C here. The first two, we get x equals 25 and x equals 27 root 3. Here, it's log base 6. X times x plus 5 is equal to 2. Yeah.
For A, isn't it? Yeah, it's like 4. So then we log 35.
Oh, it's x to the 4. So then it would be 5. Whoops.
Is it okay if we multiply it out? Or should we keep it in that?
Huh?
Is it okay if we multiply it out? Like if we got the decimal, should we keep it as right?
Oh no, radical. I prefer radical. Okay. All right. Thank you. And okay, so we're gonna do one more. What about this one? So you have log base 6 of x times x plus 5 is equal to 2. So what is this telling you? This is telling you, right, that 6 to the power of 2 is equal to what? X times x plus 5, right? Remember, this is the base. This is the exponent. So this is telling you that 6 squared is equal to x plus 5. And now 36 is equal to x squared plus 5x. So x squared plus 5x minus 36 is equal to 0. And how do we factor this? X minus 4, x plus 9 equal to 0. So x equals 4, x equals negative 9, but we know that it cannot equal negative 9. So the answer is just x equals 4. All right. One of the places where we use, here, I'll take it. One of the places where we use, what are these? Logarithms is in chemistry when we talk about pH. So you know that pH is the level of acidity of a substance, okay? And the pH scale goes from 1 to 14, where the lower the pH, the more acidic something is. So for example, like lemon has a pH of 3, right? It's pretty acidic. And the lower the acidity goes, the more acidic it is. So something with a pH of 1 would be more acidic than something with a pH of 3. 7, water, for example, is neutral. It's neither acidic nor basic. If it's not an acid, it's a base. Water is neutral, it's got a pH of 7. And then once you go on the other side of the scale, pH of 8, 9, 10, 11, it's no longer an acid, they're a base. So something that is pH of 14 is a very strong base and a very weak acid, okay? All right, and the way it's written is this. So pH is negative log base 10 of H plus. Okay, what is H plus in the brackets? This is, so when you have a substance, like for example, water, okay? What happens sometimes is the hydrogen and the OH minus, so the positive parts and the negative parts of a molecule will separate. And the more H plus something has, the more acidic it is. So this, the brackets of H plus, this is the concentration of H plus. So how concentrated it is. Like in a liter, how much H plus ions are there? Okay. So it's written as pH is negative log base 10, or pH is log base 10, 1 over H plus. Why are those two the same?
It's log and exponents and negative exponents.
Yeah, it's like negative one.
Right, so negative log base 10 H plus, right? If the negative comes up here, then it's H plus to the minus 1, which is 1 over H plus. All right, so look at this one. What is the pH of a solution whose hydrogen ion concentration is 6.3 times 10 to the negative 3 moles per liter? So what is this? This is the concentration. This is your H plus ion concentration. All right? So we need to find the pH. So we say, okay, pH, and it's always lowercase p, capital H, pH is negative log base 10, 6.3 times 10 to the negative 3. Okay? So pH is negative log base 10 of 6.3 plus log base 10 of 10 to the negative 3. Right? Okay, so log base 10 of 6.3, we'll come back to that, but how much is this? How much is that? Log base 10 of 10 to the negative 3. Huh? Okay, so just look at this one. You're asking, what is the exponent of 10, so you get 10 to the negative 3?
So that's one over one.
Negative 3, right? So look at this one. 10 to the what gives you 10 to the negative 3? Well, negative 3. Okay? And what about the other one? So that we can plug into our calculator, and you just say log of 6.3 0.799. No, it's here. So everything together, this is 2.201 is the pH. So the log button, I don't want to do that.
You don't have to put the base.
No. So, where is it? So the log button is here. Okay? Now, your calculators have a built-in base of 10. So if it's base 10, you don't have to put any base. You just put log and the number 6.3.
Oh, but if it has a different base, you have to put it on.
Yeah, I'll show you guys later how to do that. Okay, log of 6.3. Okay? Now, pH is always given in to 1 decimal place, so pH is going to be 2.2. Yeah.
That's like in log 10 of 10, bring it up to 1.
I'll take a look later, but you shouldn't have. Okay, here we go. What is the hydrogen ion concentration of a solution whose pH is 8.5? So now we're given pH and we want the hydrogen ion concentration. So if pH is equal to negative log base 10 of the H plus concentration, okay, the pH is 8.5 is negative log base 10 of the H plus concentration. Okay, so if we bring the negative over to the other side, negative 8.5 is equal to log base 10 to the power of H plus. All right, so how would we be able to find the H plus here?
Would it be 10 to the power of -1.5?
Well, is that right?
Yeah.
Okay, right. So 10 to the power of, remember, this is the base, this is the exponent, this is the base, this is the exponent. So H plus ion concentration is equal to 10 to the power of negative 8.5. Okay? So there are 0. How much? 0, 0, 0, right? There are that many.
It just showed like 36.6.